Welcome to Zaption Tour 8-6, factoring quadratic trinomials in the form of a x squared plus bx plus c. So yesterday in class, we talked about how to factor regular quadratic trinomials that look like this, where the leading coefficient, which is the number that's sitting out in front of the x squared, is a 1. And all of the problems that we did in class look like that. So right now this is a review. So I want you guys to go ahead and factor x squared plus xx minus 27 right now. Okay, hopefully you got the right answer. You should have set up the diamond problem and put negative 27 in the top, which is right here, 6 in the bottom. And remember, you're looking for two numbers that add to 6 and at the same time multiply to negative 27. Those two numbers happen to be 9 and negative 3. So therefore, x squared plus 6x minus 27 factors into the product of two binomials of x plus 9 times x minus 3. Okay, so box number 2 is the main point of this lesson. The situation occurs when all of a sudden we have a leading coefficient that is no longer a 1. All of the factoring problems that we have done so far, the leading coefficient has been a 1, and they've been pretty straightforward diamond problems. What do we do in the case where the leading coefficient is not a 1? Like, for example, this one, 5x squared plus 11x plus 2. Well, the method that I'm going to teach you that's been most successful over the years is a method that's called splitting the middle term. So what I mean by that is this. So I'm going to write down 5x squared plus 11x plus 2, okay? The middle term is right here, is the 11x. I want to somehow split this middle term in a very special way. Now I'm going to show you how to do this, but just play along for example, okay? If I split up 11x into the following, I'd have 5x squared, what if I did this, you guys? Plus 1x plus 10x's, and then finally plus 2. So right there, do you see how I have split up the middle term? Instead of calling it 11x's, I can just cleverly call it, well, 11x's is the same thing as 1x plus 10x. Now I know what you're thinking, well, how did I choose 1 and 10? Because after all, I could have chosen 2 and 9, or 3 and 8, or lots of different combinations. How did I know to choose that? I'm going to show you in a second, but I want to give you the benefit of what this does for you, okay? Now that you have four terms here, you have 5x squared, 1x, 10x, and 2, what you can do is you can group them together, the first two and the second two, and factor out the GCF of each one. So I'm going to factor out the GCF of this term, and I'm going to factor out the GCF of that term. The GCF of the first term is just the number, or is just the variable x, so I'm going to pull that out. And that leaves me with 5x plus 1. Hopefully you see that. The GCF of this second term of 10x and the number 2 is a positive 2, so I'll pull out the number 2. And what does that leave me with? That leaves me with a 5x plus 1. Hopefully you're noticing something very important. Notice that I have a now common term between each of my factored pieces. So therefore, what I'm allowed to do now is I can pull out a 5x plus 1. So all of this is going to equal 5x plus 1 multiplied by the leftover pieces that I have factored out. X, whoops, and x plus 2. Okay? So therefore, the point that I'm trying to make here is that 5x squared plus 11x plus 2 can be factored into 5x plus 1 times x plus 2. Now, if you don't believe it, all you have to do to check is use FOIL or the box method. I'm going to go ahead and use the box method. So if I took 5x plus 1 and I multiplied it by x plus 2, if I did this correctly, I should get back 5x squared plus 11x plus 2. Look what happens here. 5x times x is 5x squared. X times 1 is x. 5x times 2 is 10x. And then 2 times 1 is 2. Do you see where the 1 and the 10 are? There they are right there. Very interesting, huh? So that gives me 5x squared plus my 11x plus 2. Okay, so this is definitely correct. So now this is the idea of what splitting the middle term is all about. In the next box, I'm going to show you how to get the 1 and the 10. Okay, I'm going to call this box 2.5. I'm going to do the same exact problem, and I'm going to fill in the gaps from going from here to here. Because remember, I showed you that I took 11x and I broke it up into 1x and 10x. So how did I do that? I'm going to show you all the steps in between, and this is the missing link here. Here's what you do. Whenever you have a coefficient out in front that is not a 1, your first move is going to be take that coefficient and multiply it by the very last number, and that number would be 10. Okay? So then you can rewrite a new quadratic as this, x squared, so drop it off, plus 11x plus 10. So all you do is take the first term and multiply it by the last term, and that number then becomes your new last term, and you drop the 5. Okay, I know this seems a little bit weird, but this is how this works. Okay? Now, look what you have, you guys. You have a diamond problem where the 10 goes there and 11 goes there. And what two numbers do you need? Well, hopefully you see the two numbers that you need are 10 and 1, because 10 plus 1 make 11, and 10 times 1 make 10. So therefore, when you solve the diamond problem in the middle step, it tells you how to break up the middle term. That's how you do it. So because I knew that, the 10 and the 1, that's how I came up with the 1 and the 10. And it doesn't matter if you put the 10 here and the 1 there, or the 1 and the 10 there. That part never really matters. All you have to do is figure out the diamond problem based off of this new quadratic that you get by multiplying the first term times the last term. Okay, let's do box 3, start to finish, new problem. We're going to factor this quadratic trinomial. I'm noticing that my first term is not a 1, so I have to split the middle term. So I'm going to multiply 3 times the number 15 and write down a new quadratic over here. And that would give me x squared plus 4x. 3 times negative 15 is negative 45. From here, I would make a diamond problem. I put negative 45 here, and I would put 4 there. Can you solve the diamond problem? Hopefully you got the two solutions to the diamond problem are 9 and negative 5. Again, 9 minus 5 make 4, and 9 times negative 5 make a 45. This information here tells me how to split up the middle term. So I'm going to have it 9x and negative 5x. So my new line of algebra is going to be this, 3x squared. I'm now going to split the 4x by the way that I've solved my diamond problem. So I'm going to have a positive 9x, a negative 5x, and then the number 15. So do you see that I have written an equivalent statement? I've just traded out 4x's for 9x's minus 5x's. Really important part. From here, I can now group the first two terms and group the last two terms and take out the GCF. Take out the GCF. Of the first term, 3x squared plus 9x, the GCF would be the number 3x. And that would leave me with an x plus 3. The GCF of the second term would be the number negative 5. So I'd pull out a negative 5, and that would leave me with an x plus 3. Hopefully you see you have a common term between each of your new factors, so therefore the answer is x plus 3 times the leftover pieces that you factored out, 3x minus 5. So therefore, 3x squared plus 4x minus 15 factors to the product of x plus 3 times 3x minus 5. Box number 4 is another example. I want to factor this quadratic trinomial. I'm noticing that my leading coefficient is not a 1, therefore I must split the middle term. So I'm going to multiply 2 times negative 7 and write down a new quadratic trinomial over here. X squared minus 13x, 2 times negative 7 is minus 14. From here, I make a diamond problem. Negative 14, negative 13. Two numbers that add to that and multiply to that. Can you find the two numbers? Yes, hopefully you realize that it's negative 14 and the number 1. When you add those two numbers up, they give you negative 13. When you multiply them together, you get negative 14. So therefore, the way that we split up the number negative 13 is going to be negative 14 plus 1. So your new line becomes this, 2x squared minus 14x plus 1x minus 7. Hopefully you still see that I've traded out negative 13x's for negative 14x plus 1. They are equivalent statements. I've just split the middle term. Now I'm going to group them. I'm going to group the first two and group the last two, and factor out the GCF of this term and factor out the GCF of this term. This is going to give me 2x multiplied by an x minus 7. This is an interesting one because it looks like there's nothing I can take out, but you can always take out the number 1, leaving you with an x minus 7. And if you don't see it, just multiply it back through. What's 1 times x? It just gives you 1x. What's 1 times negative 7? It just gives you your negative 7. So you're good to go. You're now noticing that you have the same term, so it can be factored out. X minus 7 multiplied with your leftover piece, which is 2x plus 1. So therefore, when it's all said and done, ladies and gentlemen, 2x squared minus 13x minus 7 factors to x minus 7 times 2x plus 1. Okay, here's the U-try. 3x squared plus 16x plus 5. Good luck. Hopefully you got the right answer, but if not, here's how you do it. We're noticing that the leading coefficient is the number 3 and not the number 1, so therefore we're going to split the middle term. I took 3 and I multiplied it by 5, and I got the number 15. I then did a diamond problem of 15 on top, 16 in the bottom. The two numbers that work are 15 and 1. That tells me how to split up the 16. So I'm going to have 3x squared plus 15x plus 1x plus 5. From there, I factor out the greatest common factor of each one. The GCF of the first term is 3x. The GCF of the next term is positive 1. Therefore, the answer is 3x plus 1 multiplied by x plus 5.